Just 48 hours ago, astronomers witnessed the impossible. The interstellar comet 3I Atlas suddenly erupted, glowing 6 times brighter than any model predicted. Its coma, a massive cloud of gas and dust, expanded to nearly half the size of the Sun, an alien beacon in our solar system. And here's the question: why is this mysterious traveler breaking every rule of comet science as it races toward Mars at unimaginable speed? Is it revealing new physics or hiding something far stranger? Stay with us, because what unfolds near Mars in the coming weeks could change how we understand the universe forever. Just weeks ago, astronomers confirmed that 3 Atlas is not bound to the Sun. It is our third ever interstellar visitor. Following Oumuamua in 2017 and Borisov in 2019, right now, it's traveling inward at nearly 58 kilometers per second. And as it nears perihelion at the end of October, its speed will climb to almost 68 kilometers per second. To understand just how fast that is, consider this: Mercury, the fastest planet in the solar system, orbits at just under 48 kilometers per second. 3I Atlas is moving even faster. At that velocity, it could cross the distance from Earth to the Moon in less than 2 hours. The Apollo astronauts needed 3 full days for the same journey. This is no ordinary comet. It's a one-time traveler from beyond our solar neighborhood. And every moment we track it brings us closer to unlocking its secrets. In just 2 nights, 3I Atlas shocked astronomers by leaping from magnitude 16 to magnitude 12, an increase of nearly 40 times in brightness. Its coma, a vast envelope of gas and dust, expanded outward until it stretched nearly 600 kilometers, almost half the diameter of the Sun, and yet the nucleus itself remains hidden, concealed deep within this growing cloud. Estimates suggest it could be as small as 300 meters or as large as more than 5 kilometers across. This sudden outburst defies everything we know about ordinary comets and raises a haunting question: what kind of forces are truly at work inside 3I Atlas? 3I Atlas is following a hyperbolic orbit, making it a one-time visitor to our solar system. Once it leaves, it will never return. Its closest approach to Earth has already passed. No closer than 8 astronomical units, about 270 to 300 million kilometers. There is no risk of impact. But the urgency lies in something else. The viewing window is closing. As the comet nears Mars, the solar elongation shrinks below 30 degrees, making it nearly impossible to distinguish its faint glow from the Sun. By late October, as it reaches perihelion just 36 astronomical units from the Sun, 3I Atlas will be racing at nearly 68 kilometers per second, yet it will vanish into solar glare. Invisible from Earth, the timing is unforgiving. Just as the comet grows most active, will direct view disappear. The sudden brightening of 3I Atlas triggered a global scramble among observatories. Amateur astronomers were the first to flag the comet's 6-fold increase in brightness. Within hours, major facilities switched into emergency target of opportunity mode. The Hubble Space Telescope carved out rare ultraviolet slots, capturing the swelling coma in fine detail. The James Webb Space Telescope, despite its overscheduled calendar, secured precious mid-infrared spectra, revealing a shocking CO to HO ratio of 7. Ground-based giants like Gemini South and the Very Large Telescope joined the effort, snapping optical and infrared frames to track subtle changes. Even NASA's not built for rapid follow-up, adjusted its scans to catch slices of the comet's evolving spectrum. This global choreography felt less like routine comet science and more like a planetary defense drill. And with every passing night, the race against time only grew sharper. As Earth loses its direct view, the responsibility shifts to spacecraft already orbiting Mars. NASA's Mars Reconnaissance Orbiter, with its HiRISE camera, has the resolution to detect features as small as a desk. If geometry and lighting cooperate, it could even glimpse the nucleus of 3I Atlas. ESA's Mars Express contributes with its high-resolution stereo camera, ideal for capturing the full sweep of the comet's coma and tail in color and 3D. The ExoMars Trace Gas Orbiter carries instruments like CASSIS for imaging and NOMAD for spectroscopy, capable of probing the elevated CO levels detected by JWST. NASA's MAVEN mission adds yet another perspective, measuring ultraviolet emissions and plasma interactions between the comet's outflow and the solar wind. Together, these orbiters form a synthetic observatory, each offering unique tools to decode the comet's secrets. In September, astronomers were stunned when 3I Atlas shifted from a muted red to a vivid green. Normally, comets glow green because of C2 molecules, the swan bands that light up under sunlight, but with 3I Atlas, those expected signatures were missing. No swan bands, no carbon chains. Instead, the James Webb Space Telescope detected an unusually high CO to HO ratio, about 6:1. This pointed to another culprit, atomic oxygen, emitting a forbidden green line at 5,577 angstroms. When molecules break apart under solar ultraviolet radiation, the eerie green glow of 3I Atlas may not just be a color, it could be the chemical fingerprint of a world forged in another star system. As if the green glow wasn't enough, 3I Atlas revealed another surprise, a strange anti-tail pointing directly toward the sun. Normally, a comet's tail streams away from the sun, pushed by radiation and the solar wind, but in this case, large dust grains, at least 10 microns across, were launched sunward by uneven jets of carbon dioxide erupting from the nucleus. These heavier grains resisted solar wind pressure, surviving long enough to create the illusion of a tail pointing the wrong way. Meanwhile, the ion tail behaved exactly as expected, stretching away from the sun in a separate blue stream. Scientists describe this anti-tail as natural physics pushed to its extreme, but they also warn if it persists after perihelion, it could point to something new, something we don't yet understand. As 3I Atlas nears perihelion, astronomers are preparing for 3 possible outcomes. The first is a fade. The comet slowly dims as its volatile ices are spent, leaving behind a shrinking coma. The second is a flare, a sudden burst of brightness caused by fresh pockets of gas erupting from beneath the surface. And the third is fragmentation. The nucleus cracks apart under the stress of the sun, breaking into multiple pieces before fading away. Each outcome tells a different story about the comet's structure and chemistry. Which one will it be? That question haunts astronomers worldwide, and the answer may come in just days. 3I Atlas is more than just a comet. It is a natural laboratory from beyond our solar system. Every burst of gas, every shift in color, and every fragment of dust carries chemical signatures forged in another star's nursery. By studying it, scientists can test and refine models of how comets form, survive interstellar travel, and interact with the new star system. The lessons go beyond curiosity. The data feeds directly into planetary defense, preparing us for the day when an interstellar visitor may not be harmless. In many ways, 3. Atlas is a messenger carrying the chemistry of another world and reminding us how fragile, yet deeply connected, our universe really is. Let's step back and recap what we've uncovered about 3. Atlas. In just 2 nights, it brightened sixfold. Its coma swelling to nearly half the size of the Sun. It's racing toward perihelion at speeds up to 68 kilometers per second. On a one-time hyperbolic path through our solar system, its eerie green glow, powered not by carbon chains but by atomic oxygen, is rewriting what we know about comet chemistry, and its strange anti-tail, pointing directly at the Sun, challenges even our most trusted models. Now the world waits as 3 possible fates loom: fade, flare, or fragmentation. The key dates are already on the calendar: October 21st for blackout, October 29th-30th for perihelion, and November for its reappearance. Stay tuned, because what happens near Mars in the coming weeks may change our understanding of the universe forever. What do you think is driving the eerie green glow of 3I Atlas atomic oxygen? Or something far stranger? Share your thoughts in the comments. And type the word green if you'd like us to create a deep dive episode on this mystery. And don't forget to like this video, share it with fellow space explorers, and subscribe for the next updates as 3I Atlas approaches its defining moment. The story is far from over, and the next chapter could change everything we know about interstellar visitors